first hour to kind of give them an idea of where an ellipse is, where it comes from. An ellipse is one of our conic shapes that we're going to look at. And an ellipse is drawn by a set of points whose sums of the equidistant. Let me rephrase this. An ellipse is a set of points around an object that the distance that they are from the two foci remains constant. Again, it sounds a lot weirder for something that goes pretty simple. In this case here, this ellipse has a center. It's in the middle. All of our ellipses will have a center. Today, just like we've been doing, everything's going to be centered at the origin, so you have to worry about it. Each ellipse will have two vertices. The vertices will either be left and right or up and down. To go along with each vertice, just like they did with parabolas, each vertice opened up to look at its focus. It just so happens that there's two vertices for an ellipse, which means there are two foci. Vertices, they're going to go left and right. If it's squished left and right, see how it's oblong that direction? And if you turn your head like this, it's now switched up and down. We'll get to the algebra of this in a minute. That means when it's squished left and right, these points up and top and bottom will be called what are called co-vertices. And I'm going to go through all of this and how everything works out and what do all the different parts of these equations look like. And as once we get down with the nomenclature, labeling, lettering, as we get through all of that, once you understand what all the parts mean, it's super, super, super easy. Good high five. Anyway, so what I wanted to show you guys here was just what it looks like. We're not going to have to worry about calculating these values in here and stuff, just the idea of where it shows from. So here's what happens. We have two formulas for an ellipse. Remember, everything is it too dark in here? Can we kick a light back on? Anyway, you'll be fine. That's a Metallica song. Anyway, what's the difference between those two formulas? The order, the A and the B. It's x squared over a squared plus y squared over b squared equals 1. And the other one is x squared over b squared plus y squared over a squared equals 1. And you're right. Your spidey senses picked up on that the a's and the b's moved around. The reason being is that helps us decipher which direction things are moving. With ellipses, the a squared value is always greater than the b squared value. The a squared value is always bigger than the b squared value. That's how you're able to tell what direction these things are being squished or stretched. So if the a squared value happens to be like the larger of the two numbers is underneath the x squared term, it means it's being stretched left and right. By process of elimination, if the a squared value is under the y squared term, which way is it being stretched? Up and down. Okay? That's what this looks like. And that's how I always start talking about the ellipses. That way we understand where things are going. Okay? Now you're probably sitting there going, oh my God, there's A's and B's and X's and Y's and all this junk, and pretty soon I'm going to throw another variable in there too. But every single one of these things has a reason for it being there to help show how this works. And once we get it going, it's super easy to work with. I'm going to start with just this example and just kind of plot through with no numbers yet, explaining how the A values and B values correlate to one another, okay? So if I have an x squared over a squared plus y squared over b squared equaling 1, we know that this is stretched left and right. Plus, if you look at your apps in your calculator, if you look at the ellipse one, see how you have the x minus h20 squared, y minus k, that's when it's shifted. We'll get to that next week. See how the a and b are switched here? If you look at the diagram, when the a squared term is underneath the x, you can see that it's stretched left and right. When it's under the y, it's stretched up and down. And that's the thing, you don't have to memorize all this stuff. You just have to remember that a squared is bigger than b squared. That's what you have to remember with this. And then the rest of it falls into place. Okay? Not bad. So here's what it looks like. Today, everything's going to be centered. Our center will be at the origin. So I'm going to put a little grid. There's my center. And then I'm going to start listing out what the parts stand for. This value of A is the distance from the center to the vertex. A is the distance from the center to the vertex. But our problem deals with, or our formula deals with in terms of A squared. So if I needed to figure out what A was, what would I have to do to A squared? I'd have to square root it. So if you think about it, you're starting with an A squared value. If I take the square root of it, I'm going to get a plus or minus, won't I? This is where I make sure I do a plus minus, because if A squared happened to equal, I don't know, 9, for example, that means my A value would be plus or minus 3. Are you okay with that? Thanks. So just for rough ideas, so you see that's why when you have a center, you move to one direction, you move to the vertex so many units, you move to the other vertex so many units, going both ways. Okay. So I'm just going to mark off, let's just say 3 for whatever. Those are my vertices. My vertices today, if it's stretched left and right, will be at some value of A, comma 0, and the opposite of A, comma 0. That's how that works. Same deal with the covertices. Covertices are the B values. B is the distance, substance, you can see, the distance from the center to a covertex. A covertex. Yeah. The covertex has a shorter distance to get to than the vertex, because that means it's being squished. That way you can stretch out the other way. Okay. So again, if I take a b squared and I take the square root of it, that's how I get that plus minus b value, move it up and down. So just for a dumb example, this covertex plus or minus b in the y category, because I'm vertex stretched left and right, that means I moved it x. Covertex moved up and down, which means I moved it y. The last part that we don't have in the formula is how do you find the focus? The focus in this case, we label it with the point C. And this is where ellipses can get a little weird. Foci are found because of this formula. C will be the distance from the center to a focus. C will be the distance from the center to a focus. And it's found by taking a squared minus b squared. Easy way that you'll have to remember this, the equation for an ellipse has a plus sign in between it. So that means to find the focus, it's minus. The equation of a hyperbola has a minus sign in between it, which means we'll use plus to find the c squared. When we put those two together, you'll start to see the relationship between it all. It's real fast. Plus, remember, your vertex has to look at the focus. So if you get a focus value that's past the vertex, you done goofed. Okay? It's going to be numerical to work with it. Let me rewrite this on the side here, and I'll show you an actual number example, and then you'll start to see, oh, this is pretty simple. So we have our things, x squared over a squared, y squared over b squared equals 1, or x squared over b squared, y squared over a squared equals 1. A squared is always bigger than b squared. For an ellipse. Hyperbola has its own rule. We'll come back to that on Monday. A is always the distance from the center. This will always remain constant to vertex. B is always the distance from the center to a covertex. This again also stays true. And then C is always the distance from the center to a focus. Foci is the plural of focus. I don't know if you knew that. And then c squared is a squared minus b squared. It seems like a whole lot of information from when you start drawing these pictures and going through the algebra on it. It's really easy. Okay? It's just a matter of you've got to remember what these values stand for. Yeah. Don't worry. You are like the worst case scenario person in here, aren't you? The sky is falling. The sky is falling. We'll get there. We're getting there. Don't worry. I promise. We'll get there. We're just learning what this stands for. I don't want to get overwhelming to that part yet. We will. Trust me. It's going to be okay. I'm trying to avoid her. Anything else? Did you have a good day off yesterday? What's up? Yes. C is the distance from the center to the foci. Yes. C is the distance from the center to the focus. And when we start plotting values, you'll see. You'll. I don't want to hate these words C, but you'll observe where it comes from. All right. Let's try an example. Let's go right to this. We'll go right to something that you have to do math with before you have to do anything. We are going to take this equation of an ellipse centered at the origin, and we're going to graph it and identify all the parts. And when I say identify all the parts, when we do quizzes and tests on this kind of stuff, I usually list out where's your center, where's your vertices, where's your covertices, where's your foci, what are your equations of your asymptotes. That comes next week. Little things like that. We'll get there. So according to, we know this is an ellipse because it's said in the instructions, write the equation or graph and identify the parts of this ellipse, which means it has to fit into the mold of either one of these two equations. Both of these two formulas of these equations both equal 1. I'm going to give you a hint. We got to get one side equal to 1, and you're not going to be subtracting 143. Divide by. It's not gross. Look at your numbers. Yes. What's 9 over 144? You should calculate it. It's 1/16. What do you think the other one's going to be? What's 16 over 144? What was so gross about that? There's a lot of it. Okay. Math enter. Math enter. If you have to do that, we'll get you back to your fraction. Or if you start with the fraction bar, we'll do that. So I'm looking at this one. Which one's bigger, 16 or 9? 16. So 16 is playing the role of what? A squared. Hey, it's A squared. So which way is this stretched? Lengthwise. It's stretched left and right. So I know right away that this one has to do this. I'm always going to draw a little diagram of what direction something's going to go as I'm going through all of it. Because I know right away that that's what it's supposed to look like. Because the A squared value is always bigger than B squared. And according to my notes, according to my diagram, according to my calculator, the little image that it gives me, it tells me that it's going to be stretched left and right. Okay? So now I start writing down parts. We know that the center is at 0, 0. We know that right away. We also know that our A squared value is how much? 16. Good. Our B squared value is 9. And then I know that C squared will be equal to A squared minus B squared. So let's figure out what A is. If A squared is 16, what's A? Thank you for saying plus minus. I appreciate that. It's going to be plus or minus 4. What is B? Plus or minus 3. The C squared value, move this up here real quick, was 16 minus 9, otherwise known as 7. So if C squared is 7, that means C is plus or minus root 7. We okay with that? All we're doing is just filling in blanks. Okay. Now, when we go to list out all of our parts, and I'm going to do this on 2 slides here. I know I have to do a vertex. There's 2 vertices. I know that there are 2 co-vertices. And I know that there will be 2 foci. And I'm going to list everything through while I'm drawing it. Okay. Where is this centered at? It's centered at the origin at 0, 0. Okay, there's my center. I know it's at 0, 0. A represents the distance between what 2 things? Center of the vertex. Since this thing is stretched left and right, which direction do your vertices go? Left and right. So I just got to count off how far. Those are my vertices then. Since I plotted those as my vertices, what are those 2 ordered pairs? 4, 0 and negative 4, 0. All I'm doing is listing what I'm just listing as I'm writing them out. Okay? I know it's got to go left and right. Those are my vertices, go left and right. Co-vertices, they have to go up and down. How many? 3. What it says so. So I went up 3, and I went down 3. 0, 3, 0, negative 3. Yes, sir. Yes, sir. Yeah, if you go up and down, you're changing your y value. The last one is the foci. C value is the square root of 7. Last time I checked, the square root of 7 was more than the square root of 4, but less than the square root of 9. Okay with that approximation? Okay, which means it's somewhere between 3 and 2. Think about it. If the square root of 7 is somewhere between the square root of 9, smaller than that, but it's bigger than the square root of 4. So if this is 2 and this is 3, it's probably like 2.6-ish, 2.7-ish. closer to 9 than it is 3. I said, sorry, closer to 9 than it is the square root of 4. So can I just say that it's like, what did I say, 2.5-ish, here-ish, and here-ish? Does it have to be exact when you plot the point? If it's a root? No. You're getting an approximation. You're going to have a lot of approximations with some of these C values. It happens. Yes, ma'am. You don't. There will be no decimals here at all. Well, if you have to, but I could also do this without a calculator. There's nothing in this that you need a calculator for. And if I do that without a calculator, I would give you these formulas. I wouldn't make you memorize it, but you still have to know what A, B, and C stand. See what I'm saying? So here, I mean, even if it says square root of 12, what's the square root of 12? What's it bigger than? And it's smaller than? So somewhere between 3 and 4? See where I'm going with that? We're not looking for. So now, which direction did I plot the foci? Left and right or up and down? Because I changed the x values again, didn't I? Which makes sense because the vertices went left and right, so the foci have to go left and right. So my vertices, I'm sorry, my foci have ordered pairs of root 7, 0, and negative root 7, 0. That's all you have to worry about. You don't have to give me decimals there. You're giving me the square root. You're giving me the exact values. Yes, ma'am. Yeah. Yeah. Exactly. Remember, vertices always look at focus. You always want to, the vertex will always focus at something. Xander, what do you got? Great question. Yeah, we don't have to worry about any imaginary roots related stuff. You don't have to do that. That's awful. So then your last thing to do is to draw a picture of a lemon head. Thank you. Well, it's not a circle. It's an ellipse. A lemon head. It's really bad. Yes, ma'am. I said this at the beginning of the hour. Go over tomorrow. Okay. So again, the idea here is, yeah, right? The idea here, guys, is that you have to know what these parts mean. The math is easy. The parts, you just gotta remember where these things go. All right, let's try another one. Okay, let's try another one. So we go again, 25x squared plus 4y squared equals 100. What are you going to do first? Divide everything by 100. Thank you for not saying subtract 99. Yo, dude, you'd be wrong. So 25 over 100 is how much? 4. 4 over 100 is? Which means, which direction is this being stretched? So we draw a little picture. We draw a picture. A squared now is what? 25, very good. So we know that a squared is 25. I know that b squared is 4. C squared is a squared minus b squared, otherwise known as 21. I'll just write that out right away. If a squared is 25, what's a? B, and then C. Very good. Just the square root of 21. Plus or minus square root of 21. Okay? We're just listing everything out. We always list everything we're going to do before you do it. It makes graphing these things so much easier. Okay? Makes doing all the rest of the work here really, really quick. You guys with me so far? I don't want to go too fast on you here. Okay. Now what am I going to do? Where's my center? 0, 0. Okay. So then we have an H and a K. No, it doesn't. No, it doesn't. Not really. No. And that's it. Again, it goes back to the idea that there's calculated or non-calculated. I knew all this stuff. I'm sorry. I'm saying, you could sit here. So let's draw a picture. Center's at 0, 0. Vertices, co-vertices, foci. There's a reason why they are like that versus farther away. The more that they are stretched, the closer they are, the wider they are. It goes with the relationship between all that. So A value, we have to go up and down 5 this time. The B value goes left and right 2. And then our C value is the square root of 21. Square root of 21 is more than the square root of 16, but it's smaller than the square root of 5. I'm sorry, 25, thank you. Smaller than the square root of 25, so it's like 4.8-ish. So somewhere between 4 and 5. Okay. Have I labeled everything? Yeah, what's left to do? Draw the lemon head. That's the lemon heads. They did that song. Right. I used the right like a kite, left like theft, and I got booed with the first hour. First hour, they don't like your snappy repertoire. I did not. So if you want to stop by first hour, I'll just write you past your first hour class so you can just give the business. No? What's that? Okay, guys, what the foci does is that every conic shape that we have, every parabola, every ellipse, every circle actually has foci, but there's a reason why they don't label. And then a hyperbola. Every curve has something that it looks at. Depending upon how far or how close the thing opens, that focal point changes. So if you think about your glasses are curved so that the image bounces. Remember how we were saying we had that directrix back here? So your glasses are curved so that way they can hit this focal point. So that way there's a balance behind it so you can see normal and not see all fuzzy. So if you wore your glasses more often, you would be able to focus your eyes like this. And that way you would have that focus of seeing this better. Or I could do this all the time and annoy you guys. Oh, no, we'll work on the single pitch. I could do this and say, and I can blow it up. Can you see it now? That's what it is. Those curves had that point to it. Have you ever done whisper dishes? You guys ever been to like the Science and Industry or the Rockford Museum where you've got the whisper dishes? Where you've got the two parabolas on the opposite sides of the room where if you stand at one spot, That's because the sound waves and how the parabolic stuff works. That's the focal point works. Yes, sir. Yeah. This is how all this works. That's how it works.
So what was happening was there was a little thing that politicians would use. You know how the politics building on the Springfield and whatnot.
Yeah.
How it's domed.
Yeah.
Yeah. Playing the sound and put it into certain areas, and people who knew those areas would come and listen to them and talk about the kind of.
Yes. Yep. Yep. Terry, you were saying something a second ago before I went to explain foci. Correct. That's very true. Or it depends. It's all built into all that. It's optometry and things like that. Yes, sir. Yes. Yes. The A squared is the largest of the values. It means A would be the biggest. Now, the only other thing that we haven't talked about with these is what happens when you have to go the other direction. Yeah, you do. Okay. So let's say you did this with parabolas. Remember how with parabolas I gave you guys the directrix location, and you guys were able to write out the equation, or I gave you the focus, and you were able to write out the equation. Everything here, again, is since we're all centered at the origin, it works out fairly cleanly. If I give you a vertex and a covertex, you need to figure out, well, first of all, what direction is being stretched, so that way you know what goes with A, what goes with B, and so on and so on. So what do you think my first suggestion would be for a problem like this? Graph it. If I know my vertex, if I know my vertex is at 0, 7, what direction did I just go to get to my vertex? Up, which means which way is the stretch? Up and down. My vertex told me to move upward, which means it's up and down. I know that right away. My covertex is there. So going into the formulas then, I have the x squared over b squared now. Since I know that it had to go stretched up and down because my vertex went up to begin with. So your value of A is the distance from the center to the vertex. How far away, or what was the value of A in this case? 7. What's A squared then? 49. Our value of B is the distance from the center to a covertex. How far to the right did I move to that covertex? 6. So my B value is 6, which makes B squared 36. Do I have to worry about the C value here at all? No, because when you start thinking about it, your distance, you're walking a distance is always positive. The fact that I went to the left just means I went to the negative value. It's still 6 units away from the center. Yeah. If you want to, absolutely. Absolutely. If it helps you visualize it better, by all means, go for it. Yes, sir. The vertex is always, since we're centered at the origin, the value of A is the distance from the center to the vertex. Now I just fill in the blanks. X squared over 36 plus y squared over 49 is 1. Okay. It's that fast. It's not bad. Again, it goes back to the idea you have to know what these values stand for. Formulas, it's simple. Okay? If I try the other one, obviously what happens here in, next week when we start moving everything around, that's when things start to get a little messy, and you have to really pay close attention to what direction things are moving to count distances. But for today, since everything starts at the origin, it works out rather clean. Well, it's the third Monday of the week. Of course I'm angry. So vertex and focus. Notice they're on the same axes, aren't they? Correct. Yep. And you start picking up on that stuff. So if you start graphing it just to get a rough idea, your vertex went to the left. As soon as you know your vertex went to the left, you should realize that, oh, it's got to go left and right. So your A value is 4. Focus is what value? A, B, or C? C. C, okay, wait. Your C value is 2. So that means we have to worry about the A squares and B squares and C squares, all that junk. If A is 4, what's A squared? Good. If C is 2, what's C squared? Okay. Now, with an ellipse, the value of C squared is found by taking A squared minus B squared. So 4 equals 16 minus what? B squared. And B squared is? 12. B squared is 12. 16 minus 12 is 4. Now you have the info to fill in the blanks. Okay. You don't have to worry about adding and subtracting roots with any of this stuff, because if your value of C has a square root in it, when you square it, what happens to the root? It goes away. Okay. So you fill it in. We have what? X squared over 16 plus y squared over 12 is 1. Yeah. When we have this type of problem, I usually just ask you to write the equation. Okay? I usually just ask you to write the equation on that one. The other ones, it'll be rough sketch and we'll label all the parts. It'll say that. This one just says write the equation. Hey, Dan, what's up? Your A value, your A squared value is always bigger than B. If A squared is underneath X, it goes left and right. If it's underneath Y, it goes up and down. Vertex is the distance from the center to the vertex. Or sorry, A is the distance from the center to the vertex. So if it tells me to go -4, that means for a vertex, I moved to the right. That means I stretched it left and right. What's the value of A? A is the distance from the center to a vertex. If my vertex is at -4, there's another one at +4. My center is at the origin. This value is A, because it's not A. What's the ordered pair? X, Y. What else we got? You spilled barbecue sauce in your Chromebook? I don't even know. I had some in here. It wasn't that. I changed this. It's online. Did anybody look online? What did I change to? I forgot. It was what? 30, 25 or something? I don't remember. I forgot what it was. Let me pull it up real quick.
It was these.
To those, please, and thank you.